So I built this preliminary circuit to test two lithium-ion batteries together. So I get used laptops, I take out the batteries, and I have to test the capacity. So I have here, I'm testing two units. The first number on both is the voltage. Then I have the current, and then the milliamp hours that I'm recording. So the really great thing about this circuit for testing lithium-ion batteries is that you can keep adding as many cells as you want. So right now I'm testing two cells together. So I have two circuits here that are identical. There's two transistors, two resistors, they get signals. I only need really 3 pins from the Arduino. So with this Arduino Mega, I think I can test maybe 20 cells together. There's a lot of pins that I can use. And with this screen, I can just cycle through. So I could just say cell 1, cell 2, and then after 10 seconds, I can refresh and have 3 and 4, and then 5 and 6, and just cycle through so that I could record the data when it comes up. So if I wanted to add more cells, I just get another breadboard here, and I get more of these transistors. I think a better one would be something that can handle more current, because I'm only going up to like 0.7 of an amp. And then in the program, which I'll show you soon, I can just copy and paste the same program, but change the variables and the pins, and then they'll all run independently. And whenever one of these is done discharging, I can just add a new cell and it resets. So this setup is fine for the electric bike I'm building. I already have 44 cells that are tested, so you see that I write each of them on here. I'll have somewhere between 60 and 100 cells, so testing 2 at a time takes a couple days, it's not too bad. But for the electric car, I'm going to have closer to 1,000, 2,000 cells, and then I could have, the 10 or 15 testing at the same time, and that'll greatly improve the speed of how long it takes to test all these cells. So this, the code that I have here, it updates every 10 seconds. And adds up to milliamp hours. So my cutoff here was half a volt. So the second cell here is stuck. It just stays here with the recorded value. You see the top one updated. So whenever I get to this, I can leave this overnight, 10, 12 hours, whatever. Whenever I see it, I can record this value. And the second cell continues until it hits its cutoff. And now actually I can replace this second cell with a new cell, and it will register the high voltage. So I have it set to over 3.9 volts. So when I put a 4-volt cell here, it actually erases this and starts over again. So I can just keep replacing cells. I don't have to update or reset the Arduino or anything like that. So now I remove this cell. So this is cell 2. I record the milliamp hours. So I say what voltage it started at. So I started at 4 volts, and I got almost 2,000 milliamp hours. So it's a very strong cell. So now what I do is I take a new cell that's charged to 4. And then when I put it in here, it'll start counting again. So I have a new cell here that's at 4.1. So I just use magnets and alligator clips to connect it. So I just connect right here, and then I can wait, and within 10 seconds it'll start counting. So this is still going now. Actually, that's done. So now on the second line you'll see cell 2. There you go. So I got about 100 cells from the local recycling place. So I got them all in this box, and what I'm doing now is I measure them with a multimeter, and I check the voltage. So I write all the voltage. So here these are super strong, over 4 volts, and some of them are just under 3. But to really know the health of the cells, I put them on the Arduino there. I have a circuit with this light bulb, and I test the capacity. So once I mark all the voltages, then I'll charge them, test all the capacities. And all these cells here should be enough to have a really strong electric bike that can run for 3 or 4 hours. So I'll use that bike to test things, and then after I'm going to build a prototype of the electric car. So first thing, I take all the batteries out and I mark the voltage that they originally have. And when I write that down, then I sort them based on voltage. So the ones that are under 3 volts, I put here. I still have a couple left, and I charge those with very low current. So this is about 50 to 100 milliamps. And I have to bring those up to 3, and then I can charge with higher current. So I have like a 3 amp charger there. So these are the ones that were very low, and then when these are at 3, I move them to this pile, and these are the stronger cells. So these can be charged at high amperage right away. And the cells here, they're over 4 volts, so these are ready to be discharged. So I discharge down from 4 volts down. So I'll have this program available in the comments. So in the beginning here, we just have cell 1, and you just say all the different variables. So you need an analog input for the voltage, analog input for the current, which is just, there's a voltage drop across this thin wire. So you can have any kind of wire that has a voltage drop where you know the ampere or the ohms, the resistance, and the voltage drop there is proportional to the current. So I measure the voltage drop here and change it into a current, milliamp hours. It's just a variable. And here, these are the 3 pins. So you need 2 pins, one for voltage, one for current, and one is a digital pin to turn on and off the transistors. So the same is for cell 2, but just with different names. Now you start the loop here. There's some stuff about the pins. So these are output pins, turn on and off cell 1 and cell 2. And then you calculate the volts here. And then you have this if statement. So there's this done if it doesn't equal 1. So when it hits half a volt or whatever your cutoff voltage is, then this will turn to 1 and it will skip this loop. So first it takes the voltage and then it sees if it's not done, then it won't go through here. And this is where they record everything and add up the milliamp hours every time, like milliamp hours equals milliamp hours. So this is you're adding up the rectangle of milliamps from each. It's like an integration, and then you print all the variables here. So you have your amps, your milliamp hours, and your volts. You print those. And then you have an if statement, if it gets less to a value. So I'm measuring not directly on the battery, so my voltage is a lot, the actual battery voltage is a lot higher, so you never want the battery to go this low. But with trial and error, this is the settling voltage of the battery is about 3 after it goes down this far. So you say off equals low, so you put the pin to low and that shuts off the transistor. And that's it, that's cell 1. So if you hit this, you put done equals 1, and if done equals 1, then you skip this entire loop. And that keeps it off, because it turns off at the bottom, and it keeps it off. Because otherwise, when you come back into this loop, the voltage will recover and come up again, so it won't be over at this, so you won't keep turning it off. It'll stay on. And then actually to turn it on, at the bottom you have a reset for each cell. So if the volts are greater than 3.9, so that's when you reset, when you put a new cell in. This is true, so done equals 0 now. So you're going to go back into that loop and continue recording, and you reset your milliamp hours, and digital equals high, so that means turning back on the circuit. You give power to the transistors, and current flows through the circuit again. So these are 45 cells that I already tested. Most of them around 200 milliamps. So the circuit I made there, it works really well. I've done this over the past couple days. It's very reliable. You just keep switching cells and it just keeps going. Keep it plugged in for a couple weeks if you want. And these are the cells that I still need to test. So I'm going to have somewhere around 60 for my electric bike.